solving exponential equations. What we're going to be doing is looking at a very particular type of exponential equation and how to solve that. The reason for it is because you have not been introduced to the inverse function to exponentials, which would be logarithms. Once we do introduce that to you, you will be able to solve much more complicated problems. But for now, what we're going to be looking at are really convenient, easy problems where you can apply a certain trick to them. All right, so what we really want to do first is take a look at a certain property. If b to the x power is equal to b to the y power, then x has to equal y. Okay, if your base is the same here and you're raising it to the x power and you're also raising it to the y power and the result of that is supposed to be the same thing, the only way that that can be true is if those exponents happen to be equal to each other. Okay, so we're going to be using that in a little while to set up our problems. We're going to be able to get away from having exponentials and into having something that is not exponential. Now, the only real challenge that you're going to see in these problems is that you need to have the same base. If you don't have the same base, then you can't actually apply this rule. Okay, so for example 1, what we're going to do is look at a lot of different numbers here and show that you can actually express these as 4 to some power. We can let the base be a 4. Okay, like 16. 16 is actually just 4 squared. All right, 1/16. It's a lot like this. We are going to need that 4 to the second power, but we do need to create a reciprocal as well. And you can do that by using a negative exponent. So this is going to be 4 to the negative 2 power. The 2 is going to square it, make it 16, but the negative is going to create a reciprocal. Okay, 64, that is just 4 cubed. All right, so 2. How do we take 4, raise it to a power, and actually get a 2 out of that? Okay, so what is really the connection between them? Well, 2 is actually the square root of 4. And a square root can be represented as an exponent. It would be the 1/2 power. So this is 4 to the 1/2 power. That actually creates a 2. And now 8. All right, of course, 4 times 2 is going to give you 8. But what we need to do is raise 4 to a power to get to the 8. Okay? And what's neat about this is what you really need to do is take the 4 and shrink it down to a 2. We need to do this. We need to take 4, raise it to the 1/2 power to get it down to a 2. And then if you cube that, if you cube 2, you actually get 8. Okay? So what we're actually going to do is write this as 4 to the 3/2 power. Okay? That 2 as a denominator is actually going to give a square root to the 4. It drops it down to a 2. Then the 3 is going to cube it, bringing it up to an 8. And last, the most trivial case of all, you can literally take any base you want, including base 4. If you raise that to the 0 power, you get 1. All right, example 2. Let's go ahead and solve this. What we have is a base raised to a power set equal to another base raised to a power. The exponents include our variables, which we're going to be solving for. What we're going to want to do here is make sure that our bases are the same. Okay, right now we have a 4 and we have an 8. If we can make those bases the same, then we can apply that rule that was mentioned at the very beginning where we just set our exponents equal to each other. Okay, so we want to think about the 4 and the 8 and their relationship. And really think, is there a certain number that we could raise to a power that produces 4? And then that same number could be raised to a power to create 8. And there is, and that number is 2. 4 is the same thing as 2 squared. And 8 is the same thing as 2 cubed. So what we're going to do is substitute those in for the bases. So we're going to have 2 squared, and that is going to get raised to the 6n power. And this is going to be equal to 2 cubed raised to the n plus 1 power. Now here's the really important part. When you raise an exponent to another exponent, you want to use what's called the power rule. And for the power rule, what you're going to do is multiply those exponents. So this becomes 2 to the 12n power. Okay, it's not going to be 2 raised to the 6th power. Okay, that would give you a very large number. It's actually just going to be 2 times 6n, so you get 12n. Okay, and over here, we're going to need to multiply the 3 to the n plus 1, which does involve some distribution. We get 2 to the 3n plus 3. Okay, and now that we have the same base, you can really just eliminate this. It's more of a logic idea here. And we can say that 12n has to be equal to 3n plus 3. And now you have a really simple equation to solve, right? Subtract 3n from both sides. We're going to get 9n is equal to 3. You then divide by 9, and n is 1/3. All right, and just to verify that this does work, what I'm going to do is store 1/3 into my calculator. Okay, I'm going to type in 1/3, then I'm going to store it. I'm going to call it letter A. Okay, so it's going to be saved under that letter. Every time I press A, I get 1/3. And now what I'm going to do is go back and type these expressions in. So we got 4 raised to the 6a power, and I get 16. Okay, and I'm going to type in 8 raised to the a plus 1 power, and see that that also gives me 16. All right, for example 3, basically the same procedure. What we have are 2 different bases raised to powers. Your variable is in those powers. We're going to be solving for that x. All right, 1/2 and 8. We need to build the connection between them. And it ends up that that connection is the same connection that we saw in example 2, which is using the base of 2. Okay, 1/2 is the same thing as 2 to the -1 power. It just creates a reciprocal when you use a -1 as an exponent. Okay, and then 8, then 8 is going to be equal to 2 to the 3rd power. So we're going to substitute those in. We're going to take 2 to the -1, raise that to the 4x plus 1, set that equal to 2 cubed to the 2x plus 1 power. Okay, and then again, with the power rule, we need to multiply these together. Okay, when you multiply by a -1, you're really just going to change the signs there, and you are distributing because you got 2 terms. Okay, so we're going to end up with 2 to the -4x minus 1 power, which will be equal to 2 to the 6x plus 3 power. Okay, and then we can remove the base and just focus our attention on the exponents. We've got -4x minus 1 is equal to 6x plus 3. We can go ahead and add the 4x over. At the same time, we could go ahead and subtract the 3, move that over, which is going to give us -4. Okay, we divide by 10. X is going to be equal to -4/10, which is the same thing as -2/5. All right, and let's check that in the calculator. I'm going to save this value. Okay, and then I'm going to go back to the original equation and type in each side of that. So we've got 0.5 raised to the 4 times a plus 1 power. Gives us that. Doesn't look too pretty, but that's what it is. Okay, let's see if the other one works. We got 8. We're going to raise that to the 2 times a plus 1 power. And we get exactly the same thing, which means this is the correct answer. All right, for example 4, the biggest difference that we're going to see here is that we do have an inequality symbol. But to be honest, it doesn't really make that much of a difference. The only point that that comes into play is whether or not you divide or multiply by a negative number. And in many cases, you can actually avoid doing that altogether, okay? So if it makes any difference in the problem, we'll see it when it happens. If it doesn't, you basically just pretend that this is an equal sign. All right, so what do we have here? We've got a base of a 3. There's not really much that you can do with it. It's already a very small prime number, okay? What we might want to do is take a look over here, okay? We've got 1/243. And you may not know this initially, but 243 is based on the number 3. All of its prime factors are 3, okay? So let's explore a couple things here. All right, of course, 3 squared is going to be 9, and 3 cubed is 27. Okay, 3 to the 4th power is 81. Okay, that's the same thing as 9 times 9. If you take 3 to the 5th power, it's actually 243, which is what we see here, except that our 243 is in a denominator, so it's a reciprocal, which means that if 243 is equal to 3 to the 5th power, then 1 over 243 is going to be equal to 3 to the negative 5 power, okay? So that's what we're going to do. We're going to make an even swap here. We're just going to take this out completely and replace it with 3 to the negative 5. All right, and then we get to leave this alone. So we've got 3 to the 2x minus 1 is greater than or equal to 3 to the negative 5. We'll then drop our bases. So we get 2x minus 1 is greater than or equal to negative 5. We'll solve from here. We'll go ahead and add the 1 over. That's going to give you negative 4. So you're going to get 2x is greater than or equal to negative 4. Divide by 2 on both sides, and you get x is greater than or equal to negative 2. And that's your answer. We did not need to divide or multiply by a negative number, so the inequality never flipped. Didn't do anything in there. You can just basically pretend that it's an equal sign throughout.
Wait, what?